Imagine standing on a beach at what should be high tide. But the water is still. It's unnervingly calm, resting far down the shore where low tide should be. The rhythmic surge you have known your entire life, the ocean's slow and steady breath, has simply stopped. The waves that wash ashore are now just small ripples, driven only by the wind. The great pulse of the planet's oceans, a force that has shaped coastlines and life for billions of years, is gone. You look up into the night sky, searching for that familiar silver disk. It's not there. Nothing is there but the pinpricks of distant stars in an unnervingly dark void. And you ask yourself a simple, terrifying question. What would happen if the moon just disappeared? This isn't a slow fade. It's not a cosmic explosion. At the stroke of midnight, on this day, 2025, October 28th, the moon, all 73.5 quintillion tons of it, vanishes. The most immediate and dramatic effect of the moon's vanishing act would be on our oceans. The moon is the primary driver of our tides, its gravity pulling a massive bulge of water toward it as the Earth rotates. The sun also contributes to tides, but its effect is much weaker, only about 40% as strong as the moon's. Without the moon, this immense lunar pull vanishes in an instant. The massive bulge of water it held in place would suddenly be released. This would trigger a colossal planet-wide tsunami as the water sloshes back, seeking equilibrium. The oceans would oscillate, ringing like a planetary bell, with waves potentially hundreds of feet high in some areas, before settling into their new, much calmer state. After this initial chaotic sloshing, a new tidal pattern would emerge, governed only by the sun. These solar tides are much smaller. Instead of tides that can rise and fall by several meters, in places like the Bay of Fundy, over 16 meters, we would be left with tides of perhaps a meter or less in most places around the globe. The familiar rhythm of 2 high tides and 2 low tides each day would be replaced by a much simpler, weaker pulse. Coastal areas would effectively have a new, permanent shoreline, somewhere between the old high and low tide marks. The new, placid oceans would spell doom for entire ecosystems. The intertidal zone, that rich and diverse strip of coastline exposed at low tide, submerged at high tide, would be the first casualty. This habitat is home to a staggering variety of hardy organisms: barnacles, mussels, starfish, crabs, all exquisitely adapted to the daily cycle of wet and dry and the alternation of calm and chaos. With the moon gone, that cycle stops. Upper tidal creatures, the water will never return. They'd be left high and dry, desiccating and dying within hours or days. A mass extinction event on a global scale along the world's coastlines. Lower tidal organisms, the sky would never appear again. They'd be plunged into a permanently submerged world. A sudden, drastic change. Species like certain algae that need periodic sunlight would perish. The entire coastal shelf food web would be thrown into chaos. Predators that hunt tidal flats would find grounds permanently flooded or a barren wasteland. Immediate, severe consequences for humans. Coastal fishing industries rely on tidal productivity. Many important fish and shellfish use these zones as nurseries. Collapse of the intertidal zone means catastrophic decline in fish stocks, crippling economies, and threatening food security for billions. The disappearance of the moon would send shockwaves through human culture, technology, society. For millennia, we have used the moon as a timekeeper. Many calendars, Islamic calendar, Hebrew calendar, are lunar or lunisolar, months defined by lunar phases. Without a moon to observe, those systems would become historical artifacts overnight. We'd rely solely on the solar, the Gregorian's calendar for scheduling. The very word month from moon would lose its original meaning. It would become an abstract division, not a visible celestial cycle. Our relationship with the night would be fundamentally altered. Loss of moonlight would hit agriculture and electricity grids. Farmers who time planting or harvesting by lunar cycles would lose their guide. The biggest change: demand for artificial light. Cities would become brighter. Rural areas would need extensive lighting for safety and navigation. Global energy use would rise, straining power grids and adding light pollution. That pollution would obscure the now brilliantly starry sky, trading natural moonlight for artificial glare. Navigation, ancient and modern, would be impacted. Centuries of sailors used the moon to fix their position at sea. Today we have GPS, but it's not infallible. If satellite navigation failed, traditional celestial methods are critical backup. Without the moon, a key celestial signpost would be gone, making navigation harder. Even advanced tech depends on the moon. Some satellite orbits are calculated with lunar gravity in mind. Its sudden absence would force immediate, complex orbital corrections to prevent drift or collisions. While the immediate effects of the moon's disappearance would be dramatic, the long-term consequences for the planet itself are even more staggering. The moon acts as a stabilizer for Earth's axial tilt. Its obliquity. Earth is tilted about 23.5 degrees relative to its orbital plane. That tilt gives us the seasons. The moon's gravity is like a steadying hand, preventing wild changes to that tilt. Without the moon, gravitational nudges from other planets, Jupiter, Saturn, would have much more influence over long timescales. Over thousands to millions of years, Earth's axial tilt could wobble chaotically. Instead of gentle variations over tens of thousands of years, the tilt could swing to nearly 0 degrees, no seasons, or shift to around 45 degrees or more. That dramatic shift would devastate our climate. Summers could become scorchingly hot. Winters could become unimaginably cold. Ice caps might melt entirely, or ice could extend down into the mid-latitudes, triggering extreme ice ages. The stable climate that allowed complex life for millions of years would vanish. Long-term, stable ecosystems would struggle to exist. Life would have to adapt to extreme, unpredictable climates. Agriculture as we know it would become impossible. Temperate zones, today's breadbaskets, could flip between tropical paradise and frozen wasteland over geological time. This wouldn't happen overnight. It would take many millennia to become severe. But it would seal the planet's fate. Earth would grow far more hostile and unpredictable, much like Mars, believed to have undergone wild tilt swings. Earth's orbit around the Sun would change very slightly. The Earth-Moon system orbits a barycenter about 4,700 kilometers from Earth's center, still inside the planet. If the Moon vanished, Earth's small monthly wobble around that point would stop, and Earth would settle into a smoother path around the Sun. That would minutely change our year length and distance from the Sun, but not enough to matter for daily life. The real danger is not our orbit, it's our increasingly unstable spin on our own axis. The disappearance of the Moon would mean the immediate and permanent end of one of nature's most awe-inspiring spectacles. The eclipse. A total solar eclipse. When the Moon passes directly in front of the Sun and casts a shadow upon the Earth. It's a breathtaking cosmic coincidence. The Moon is about 400 times smaller than the Sun, but it is also about 400 times closer, allowing it to appear to be the exact same size in our sky. This perfect alignment has allowed us to study the Sun's corona. It has struck fear and wonder into human hearts for all of history, and would never happen again. Similarly, lunar eclipses occur when the Earth passes between the Sun and the Moon, casting its shadow on the lunar surface. They would also cease. The beautiful and eerie blood moon would become a phenomenon confined to history books and photographs. These events were not just beautiful, they were scientifically crucial, from measuring Earth to testing relativity. And the end of the Moon would end our plans for it. Bases, mining, a stepping stone to Mars, vanishing along with the Moon itself. In the end, what would a world without a Moon be like? It would be a darker, it would be quieter, it would be a more extreme planet. The oceans would be placid, their great tidal breath stilled forever. The rich ecosystems of the coasts would be gone, replaced by a stark, static shoreline. Our nights would be plunged into an inky blackness, lit only by the distant, cold light of stars. Human cultures would lose an ancient source of myth, timekeeping, inspiration. Over millennia, our planet's stable climate would begin to unravel. The Earth would start to wobble on its axis without its gravitational anchor, leading to unimaginable swings between heat and ice. But humanity would not perish overnight. We are a resilient and adaptable species. We would adjust, build new economies, develop new technologies to light our nights, create new calendars. We would find new stories to tell, new wonders to behold in the cosmos. We would learn to live in this new world. Imagine yourself, years later, standing on that quiet shore. The sea is calm, its surface like black glass reflecting a sky ablaze with billions of stars. There is no silver path of moonlight on the water, only starlight, ancient and faint, and the deep silence of a world that lost its partner but continues to spin. We would adapt. We would survive. But we would forever be haunted by the ghost of a memory, the memory of a time when we could look up and see the moon, and know that we were not entirely alone in the darkness.